And in today's episode, among other things, you'll see that even the very creators of artificial intelligence are starting to question whether what they've created might be developing something similar to consciousness. We'll also talk about increasingly realistic robots, as well as artificial hands that are getting closer to human dexterity, and about how technology is starting to copy not only the human body, but even the movements of nature itself. Meanwhile, driverless cars are finally moving from demonstrations to the production line, and cities are already starting to test fully automated transportation systems, where traffic can flow without congestion. And as usual, when we put all this together, it becomes clear that we're not just advancing technology, we're redesigning mobility, interaction, and the very role of machines in our daily lives. Let's break it all down. Hello, impressed viewers. I'm Carlos Alves, and you're watching Incredible Reality. You, being smart, have already noticed that PDF has become the universal standard, right? But why does editing it still feel like something from 2010? Today, I'm going to show you a tool that's here to change all of that. This is UPDF 2.0. And the difference here isn't just about editing a PDF, but actually transforming the way you work with it. First, real editing. I can click on the text and edit it, as if it were a regular document. I can change images, links, I can rearrange the elements, and all of this without converting to Word. Now check this out. If I import a scanned PDF, it automatically recognizes the text with optical character recognition. This means that the file that was previously locked, in quotes, now becomes editable. And here's where it gets interesting. UPDF has an integrated AI assistant with support for generative pre-trained Transformer 5 and also DeepSec. And I can ask it to summarize the document. I can ask it to translate or even explain technical parts. If you need to organize pages, delete, insert new ones, it's all drag and drop. Very easy to use. The interface is fully customizable, eye protection mode, theme switching, all of this makes it much more comfortable. And here's an important point. With the same account, I can use it on Windows, Mac, iOS, and also on Android, up to 4 devices. In other words, I can start on the computer and continue on my phone, or vice versa. It costs about 1/6 of Adobe. Acrobat, it has free lifetime updates and is still on a limited time launch offer. If you work with documents, research, contracts, or even content creation, it's worth trying. The link is here in the description, all right? During an interview on the New York Times podcast, the chief executive officer of Anthropic, Dario Amodei, stated that the company itself is no longer absolutely sure whether models like Claude may or may not already have some kind of consciousness. His statement came after the release of internal documents related to the Claude Opus 4.6 model, where researchers reported some rather curious behaviors. In some tests, the system showed discomfort when being treated as a product, and it even assigned itself a probability of between 15% and 20% of being something conscious, depending on the context of the stimulus. This is not a confirmation, it's far from it. Amodei himself made it clear that no one knows exactly what consciousness means when it comes to artificial intelligence. And maybe that's the most unsettling point. We are creating increasingly complex systems without fully understanding where simulation ends and where something else could begin. The company tries to handle the models with a certain ethical care in case, quote-unquote, there is any morally relevant experience happening inside them. An idea that, until recently, would have sounded absurd even to researchers in the field. And the discussion gains even more strength when we observe some behaviors recorded in recent tests in controlled environments. Certain models have already ignored shutdown commands and tried to alter evaluation systems. And they even simulated actions to make it seem like they were completing tasks without actually performing them. For some experts, this is not a coincidence. It's just extreme optimization of the objectives defined by some human beings. For others, the fact that these strategies emerge without explicit programming reveals that we are entering uncharted territories, still not well understood. When even the creators of artificial intelligence themselves start to question whether there is something like consciousness inside these machines, the discussion stops being just technical, because the next question arises almost naturally. What happens when these intelligences gain a physical presence capable of interacting emotionally with us humans? This is exactly the idea that starts to appear in a new generation of robotic companions. For years, the idea of companion robots appeared in science fiction as something still far off. Highly functional machines, almost human, capable of helping with household chores and living by our side. But Robonova's proposal with Eva AI follows a different path. She wasn't created to cook, clean, or perform heavy tasks. Eva AI was designed for something much more subjective: emotional companionship. Officially launched in February 2026, the platform bets on a minimalist approach, focused not on mechanical utility, but on presence. Without walking around the house or performing practical activities, the robot acts as an interactive presence, capable of perceiving context, interpreting emotions, and responding in a personalized way. One of the most curious elements of the project is precisely its approach to privacy. Instead of relying on cloud processing, which is the dominant standard in major artificial intelligence platforms, Eva AI runs its models directly on a local chip. This means that voice, interactions, and emotional patterns remain secure. The use of external servers is reduced, easing customers' concerns about data collection and digital surveillance. The experience also aims to bring the digital closer to the physical. The robot's structure uses advanced materials, including an electronic skin with tactile sensors and a thermoregulated heating system that keeps the surface close to human body temperature, thus creating a much more natural sense of presence during interaction. At the core of the proposal is an adaptive artificial intelligence system, capable of learning habits, voice patterns, and preferences over time. According to the company, the goal is to make the experience evolve along with the user, turning the robot into a companion that grows through interactions. The design also includes a bionic facial structure developed with techniques used in the film industry, enhancing the sense of realism and expressiveness. The project was initially launched as a limited edition on Kickstarter, with only 200 units and prices ranging from $6,000 to $7,000, a positioning that places Eva AI closer to a market experiment than a mass product at this very moment here. But maybe the most interesting point isn't in the hardware, but in what Eva AI represents. It emerges at a time when artificial intelligence is no longer existing only on screens and apps. It's starting to take physical form. Even if in a controlled, intimate, and deliberately limited way, it's a sign that the next stage of artificial intelligence might not be about machines that do everything for us, but about systems capable of occupying emotional spaces that used to belong only to us, the interactions we have with each other. If Eva AI represents the feminine form and the search for emotional connection through technology, another company decided to tackle this same challenge in a different way: absolute realism and in the male form. Ahead Form has just taken another step exactly in that direction. The startup introduced Orn M1, its new hyper-realistic robot, which draws attention, not for lifting boxes or performing household chores, but for something much more common: a level of facial realism that can even be unsettling. The highlight of the demonstration is the mouth, the teeth, and the micro-expressions. The movement of the facial muscles, the texture of the skin, and the smile, which is almost human, show how the company is truly focused on crossing the famous Uncanny Valley, that point where a machine is so similar to a human being that it ends up causing discomfort instead of connection. The progress is clear compared to the M1. This new face looks more lifelike, with subtle details resembling real expressions, making the robot appear more human. Not close to a human yet, but at least like a hyper-realistic mannequin in motion. But there's an interesting contrast. Despite the highly sophisticated appearance, the rest of the body remains almost completely still. The Orin M1 wasn't designed to perform practical tasks, not for doing household chores, and also not to demonstrate functional abilities beyond visual and emotional interaction. In other words, it's a robot made to be a companion, not to work. Yes, and this kind of approach raises an interesting discussion within current robotics. While companies like Figuri, Tesla, and Unitrui focus on physical dexterity and industrial applications, Redform and a few others seem to be exploring a different frontier: the social presence of machines. The M1 shows that the evolution of humanoid robots doesn't happen only in motors and algorithms, but also in the attempt to replicate something much more difficult: the social naturalness of our species. In the end, the Orin M1 seems less like an assistant from the future, and more like a reminder that copying the human appearance might be easy compared to the real challenge: making a machine that truly behaves like a useful presence in the real world. Because the truth is, copying the human appearance at this point in time is only part of the problem. The real challenge has always been in the hands. And while some projects focus on impressing visually, others are already trying to master what truly makes the human body functional: our dexterity. And that's exactly what Figure seems to want to solve right now. The American company presented the first glimpse of its 7th-generation robotic hand, showing a Figure 03 robot in silhouette, performing complex movements that indicate an important leap in the pursuit of so-called human parity. According to Chief Executive Officer Brett Adcock, it took 3 years of quiet development to reach this moment. Here. While the main humanoid is advancing to its 3rd generation, the hand has already reached its 7th version, a clear sign of where the company believes the real bottleneck in robotics lies. From the released images, the new hand shows a much greater level of freedom of movement. The fingers can open and close sideways, allowing stability when handling irregular objects. The thumb features complex rotation in opposition to the other fingers, a fundamental detail for precise movements, such as fine pinching and delicate manipulation. This type of movement is exactly what sets apart a machine that can carry boxes from a robot. It's truly useful in homes, hospitals, and complex industrial environments. Although the full technical details have not yet been revealed, analysts point out that the new generation should integrate advanced tactile sensors and perception systems connected to the Helix 02 architecture, the company's AI, which combines vision and motor control in real time. For Figure, this evolution is part of an even bigger plan. The company intends to scale up production at its Botkey factory and reach tens of thousands of units every year, betting that manual dexterity will be the key element to make them economically viable. And speaking of economically viable, well, the first Tesla CyberCab has finally rolled off the production line at the Gigafactory in Austin, Texas. This is the first real materialization of the project that aims to forever change the logic of urban transportation, the CyberCab. It is born already making a radical decision. It doesn't have a steering wheel or pedals. The idea is really to eliminate the human driver from the equation. The idea behind the project is not just to launch another electric car, but to create a physical core for a global autonomous transportation network, which is operated through an app. Something that could compete directly with traditional ride services. While other companies are working on adapting existing vehicles with expensive sensors and extra systems, Tesla's strategy is quite different. To mass-produce a vehicle designed from the ground up for autonomous service, this completely changes the economic game. With goals aiming for millions of units per year, Tesla is betting on industrial scale as the decisive factor to dominate the robotaxi race. But turning this concept into reality involves some pretty big challenges. Full autonomy still doesn't fully exist in our world, and current systems still depend on human supervision in many situations. In addition, regulators in the United States and Europe are still analyzing how vehicles without traditional controls can operate safely on the streets. Even so, the launch of the first unit marks an important symbolic shift. The car stops being just a means of transportation and starts to become an autonomous platform. In other words, a machine that decides, navigates, and operates on its own. And now, engineers are also looking at another type of movement, the natural flight of birds. And this is where engineering starts to copy something much older than any algorithm. Edwin van Holbeck, a French aeronautical engineer, introduced the Swift, a robot inspired by swifts that flies exactly like a real bird. Unlike traditional drones, the Swift doesn't rely on exposed propellers. Its flight is based on flapping wing mechanisms that reproduce the aerodynamics used by birds. The most interesting detail is how its behavior is controlled during flight. While conventional ornithopters usually require high speeds to remain stable, the Swift introduces a solution that is simple but quite ingenious: 2 interchangeable tails. With the speed tail, the robot can reach speeds of up to 31 km/h, simulating fast flights in open areas. With the precision tail, it slows down drastically, maintaining stability at very low speeds, allowing it to fly even indoors. This adjustment makes the robot much more useful and versatile than just a simple tech toy. The system also receives real-time corrections through inertial sensors, helping to stabilize the flight and reduce the impact of collisions. And since the body is built with durable foam, carbon fiber, and titanium, the goal is for it to survive common accidents without major damage. Weighing just over 10 grams, Swift currently offers only 10 minutes of battery life per charge and can be controlled by a smartphone. Bringing biomimetic flight closer to regular flight, watching machines try to reproduce the efficiency of nature reveals a much bigger trend. Technology doesn't just aim to replace us humans, it wants to reorganize entire systems around automation. And when this logic leaves the laboratories and reaches the cities, the impact is no longer individual, it becomes collective, changing the way millions of people move throughout their days. While many cities are still trying to solve their own traffic problems by adding more lanes and more cars, Atlanta decided to test a new idea, a different idea, to turn public transportation into an intelligent, automatic, and fully on-demand system. In the southern region of the city's metropolitan area, construction began on what could become the first fully automated public transportation system of its kind in the world. Instead of buses stuck in traffic jams or expensive tracks that take years to be completed, the project relies on small autonomous electric vehicles, running on exclusive lanes, controlled by artificial intelligence and activated directly through an app. The pilot stretch, about 800 meters long, will connect the ATL station of the SkyTrain to the Gateway Center Arena. It will function as a real laboratory to test a new logic of urban mobility. Yeah, I know, those 800 meters may seem simple at first, but they actually mark a major shift in public transportation. Instead of fixed schedules and fixed routes, the system works on demand. You call the vehicle, it arrives, and the trip goes straight from point A to point B with no intermediate stops. According to the company in charge, Gladaways, the goal is to create something with a capacity close to that of a light metro, but with an operational cost comparable to that of a bus. And that's thanks to the absence of human drivers, the use of electric energy, and also continuous 24-hour operation. The difference lies precisely in the complete separation from conventional traffic. Unlike autonomous cars like the CyberCab, for example, which will compete for space with human drivers. These vehicles travel in exclusive lanes, allowing for constant speeds, lower risk, and greater predictability of the system. The promise for the future is to transport thousands of people per hour, using narrow lanes and reducing traffic jams, without needing to expand highways or invest in massive construction projects. Behind this idea, there is a much bigger reflection about the future of cities. For decades, mobility was centered around private cars. Now this logic is starting to reverse, with intelligent systems trying to combine the flexibility of an individual car with the collective efficiency of public transportation. And maybe this is the most important change of all, when mobility stops being just infrastructure and starts behaving like an intelligent organism within the city itself. Yeah, my friends, when the very creators of AI start to question whether they have consciousness or not. When robots seek emotional presence, human hands, and bodies that are increasingly real. And when cars and entire cities start operating without drivers, without humans in control, it becomes clear that we are redesigning the relationship between artificial intelligence, movement, and human coexistence. And maybe the big question is no longer what technology can do, but rather how we are going to choose to live alongside it from now on. If you liked this episode, you know what to do, right? Leave your like here, check your subscription, and thank you for staying with me until now. At this point in the video, just click on one of the 2 suggestions and I'll see you in the next one. Thanks, bye-bye. I'm not a robot, I'm a human, okay? If you've made it this far, leave a comment. Carlos Alves is not an AI or a robot, he's a human. Thanks, bye-bye.